Section 2.4 is all about symmetry. We call a figure symmetric if one of its branches is exactly the same on one side of some line as it is on the other. In other words, if I'm looking at this figure and I folded this paper around the x-axis, these lines, if I was a better artist, would match up exactly. And we call that x-axis symmetry. In this case, the figure we're looking at is y squared equals x. Now, just looking at this on the graph, it's fairly easy to tell that this figure is symmetric with respect to the x-axis. But we want to find some algebraic method of figuring that out. And the method we have is to replace y with negative y and see if we get the same equation out. So let's do that. If I replace y with negative y and work it out, I get exactly the same equation. So if we get the same equation out, that shows we do have x-axis symmetry. The next type of symmetry we're going to look at is y-axis symmetry. And pretty much the same thing as x-axis symmetry, except now our figure is symmetric with respect to the y-axis. And you're going to see the words y-axis symmetry and even function used interchangeably. They mean exactly the same thing. The test for that is to replace x with negative x and see if you get the function out, same function out. So let's try that now. And we do get the same function out. So the function y equals x squared does have y-axis symmetry. And the last type of symmetry we're going to be concerned with is origin symmetry, which means our figure is symmetric around the line y equals x. So if I drew the line y equals x, the figure y equals x cubed would be symmetric around that. And again, you're going to see the words origin symmetry and odd function used interchangeably. The test for this is a little more difficult. We have to replace y with negative y and x with negative x. So let's do that. And when we simplify and then multiply both sides by negative 1, I do get the original equation out. So y equals x cubed does have origin symmetry, and it is also called an odd function. So let's try these with some more complicated examples. Let's try y equals the absolute value of x minus 5 first. First, let's test for x-axis symmetry. And it's fairly obvious that's not going to give us the same equation. So x-axis symmetry is out. Let's try y-axis symmetry. Replace x with negative x. Absolute values get rid of those negatives. And I do get the same function out, so I do have y-axis symmetry. Now, let's just try origin symmetry. And I do not get the same function out, so it does not have origin symmetry. We do have y-axis symmetry, though. So the function y equals absolute value of x minus 5 has y-axis symmetry. Now let's try the same thing for f of x equals 8x minus the absolute value of 8x. The first thing you might want to do when you see something like this is just to replace that f of x with a y. And now let's test. Let's test for x-axis symmetry first. And it's pretty obvious we do not get the same equation out, so no x-axis symmetry. Let's try y-axis symmetry. And we test for that by replacing x with negative x. And again, the absolute value gets rid of the negative, but we have that negative there to contend with. And again, we don't get the same equation out, so we don't have y-axis symmetry either. Now let's try origin symmetry. So replace the y with negative y, and the x's with negative x, and see what we get. And even if I multiply through by -1, I do not get the same function. So we don't have origin symmetry either. So this particular function does not have any symmetry. Let's try a few more of these. Let's try 2x minus 2y equals 0. And let's test for x-axis symmetry first. And again, we do that by putting negative y in place of y and simplifying. And our function changes, so we do not have x-axis symmetry. Let's try y-axis symmetry now, which we test for by putting negative x in place of x. And again, we get a different equation out, so there's no y-axis symmetry either. Now let's try origin symmetry. So we replace the x with negative x, and the y with negative y. And it looks slightly different, but if we multiplied both sides through by -1, I would get the same equation out. So this does have origin symmetry. Okay, and let's try one more line. Let's try this one. Let's test for x-axis symmetry first. So I plug a negative y in for y. And I don't get the original equation out, so it does not have x-axis symmetry. Let's test for y-axis symmetry. And I do that by plugging negative x in for x. And again, I do not get the same equation out, so I do not have y-axis symmetry. Now let's try origin symmetry. So I'll put negative y in place of y, negative x in place of x, and see what happens. And it doesn't look like the same equation, but in this top one I was able to multiply through by -1 and I got the same equation, so we did have origin symmetry. Let's see if the same trick works down here. Let's multiply both sides by -1, and when I do that I still don't get the original equation, so this particular one has no symmetry. And let's do one more. And again, I have that strange looking f of x there, so let's replace that with a y to make it a little bit easier. And let's test x-axis symmetry first. So I replace y with negative y. And I do not get the same equation out, so there's no y-axis symmetry. Sorry, x-axis symmetry. Let's test y-axis symmetry. Okay, when I do that and simplify, I also don't get the same equation out. Remember, that's an even power, so it just gets rid of that negative. So I don't get the same equation out. I do not have y-axis symmetry. Now let's try origin symmetry. So I'm replacing y with negative y and x with negative x. And when I simplify that, well, it looks close. Let's multiply both sides through by negative 1 now. And I get the original equation out. So this one does have origin symmetry. And the last thing you need to know about symmetry is how to find points symmetric with respect to a certain axis or with the origin given another point. So let's say I'm given the point 3, 2, and I'm asked to find the point symmetric with respect to the x-axis. All that means is I'm going to reflect this point around the x-axis to the point 3, negative 2. So that's symmetric with respect to the x-axis. If you're looking for the point symmetric to 3, 2 with respect to the y-axis, same basic idea, you just flip it around the y-axis to negative 3, 2. And this is symmetric with respect to the y-axis. And if you're asked to find the point symmetric to this with respect to the origin, you have to flip it around both y and x, which brings us to negative 3, negative 2. And this point is symmetric with respect to the origin.